Let us see the De Morgan's law with respect to Boolean algebra. So, what is the utility of De Morgan's law, student? Is sometime we will be given with some logical expression and we want to find its corresponding complements. Let's say this is what one example will be solving. So, this is some expression given and here I want to find the complement of this function. So, this is the function and for this function you want to find its complements. So, whenever you have to solve a complement of a function, De Morgan's law comes into pictures. It is used to obtain complement of any Boolean function. So what we can do is, whenever removing this particular complement, what are the steps we need to follow? That is what it says. So while removing this, if you want to remove this, so each term should be complemented and operator should be replaced by or operator and vice versa. Okay. So let me take one example, students, this one, and we'll see then. But you see, let's say I have an expression something like this, a1 plus a2 plus a3 plus like this. I want to find its complement. So if you want to remove this, what you have to do? Every variable will be complemented. A1, A2, A3, these all will be complemented. And these plus, these are replaced by dots. So similarly, you want to find complement of A1, A2, A3 like this. Then it is complement of first variable A1 bar plus complement of second variable plus complement of third variable and so on and so forth. You see that each plus is replaced by dots. You see that each dot is replaced by plus. So dot operator is interchanged with plus operator and vice versa. So you have to complement each variable and each plus will be replaced by dots and vice versa. Similarly here also. Okay. And one more thing, students. So one tricky situations when a student do mistake. Suppose for example, f is a function. I can say it is a plus bc. Suppose somebody asks me to find its complements. Okay. So there could be two different approach. Okay. One could be, some people may think that if we are simplifying this, then it is equivalent to a complement dot plus replaced by dot, then it is bc complements. So it is a bar and this is bc whole bar is b bar plus c bar. Right. So if I am removing this complement, so this variable is complemented, this plus is dot, this variable is complemented. So again, if I am removing this complements, so each variable is complemented, b bar, c bar, and this bc means b separated by dot. So this is replaced by plus. So this is the answer. Okay, this is one way. But my argument is, why can't you take, so like you have taken this, you could have also done this way, na? Like you would have taken a plus b as first variable, then the c. You could have, somebody can think this way also. If so, then the answer would be a plus b whole complement plus c bar. A plus b whole complement, if you simplify, it is a bar dot b bar. You know, a is complement, b is complement, plus is replaced by dot. So a bar, b bar plus c bar. But you see, these expressions are not same. In fact, there is other way to check whether two functions are equivalent or not, but these two functions are not equivalent. So which is correct? This is correct or this is correct? So that's why, students, whenever we have, so what is the basically the problem is? The problem is, here I am taking, this is a variable, this is a variable, and in this case I have taken, this is one variable, this is one variable. In other words, so like this is the thing. So in this case, so first variable, second variables are chosen in a different way. So but the original question is to find the a plus bc whole complements. So that's why, students, in such kind of cases, whenever you have or and both, so you have, this is or operator, right? This is or and this is and operator. So whenever you have or and both, so the priority should be first and then or. While applying De Morgan's law, and operator precedence over or operator. So the priority should be to or, priority should be to and operator, not the or operator. So if somebody asks you why this is not correct, so because you have both plus and dots, dot having the highest priority. So that's why you are taking this. It's a valid question actually, right? Somebody asked me in one of the class, so I thought of to explain you. But parenthesis, if it is given, it is having highest priority compared to and or, right? But parenthesis having highest priority over and or. So in the original question itself, if this is how it is given, then this is the right answer. But if nothing is given, if only this is given, then this is the right answer, this will be wrong answer. But in the question, the bracket is given here, then this is right answer. So first priority is parenthesis, then and, then or. So you remember this property. So now students, let us simplify this expression. So using De Morgan's law, obtain the simplified expression of this one. So the expression is f is equals to complement of a, this is b plus z, this is x plus a bar. If I am removing the complements, so what I'll be doing is, so I'm putting a bracket here and putting a bracket here. So this is the dot. So if I'm removing this, it is a complement, this dot is replaced by plus, and then complement of the second one, b plus z with x plus a bar. So first variable is again c, and in this case, so this is one variable and this is the other variable. So this is plus. So first variable complement is b bar dot with z, this is x plus a bar whole complement, this one. So now again it is a bar plus this is b bar dot. If you simplify this, it is z bar. So this is one variable, this is other variable. So complement of first variable z bar. This dot will be replaced by plus, and this is x plus a bar whole complements. So it is a bar plus this is b bar dot. So this is z bar plus this. If you remove this complement again, it will be x bar dot a, x bar dot a. Yes or no? X bar dot a. So now you can again simplify this. This is your a bar plus this is b bar z bar plus b bar x bar a, b bar x bar a. So this can be written as, this is b bar z bar, students, okay? So this can be written as, so see, we have seen that a plus bc is equals to a plus b with a plus c. A plus b ANDed with a plus c. In the same logic, so a bar plus a b bar x bar. I mean this term and this term I have written, and then I'm writing it is b bar z bar. So this can be written as a bar plus a with a bar plus b bar x bar, and this is b bar z bar. So this one, this is equivalent to this, like a, yeah, a plus bc. This is a plus this is b, this is c. A plus bc is equals to a plus b plus a plus c. So what is the benefit of it? A bar plus a is 1. So this is 1 and 1 dot anything is anything. So this is equivalent to a bar plus b bar x bar plus b bar z bar. And you want to write in a more compact form, you may take this b bar as common. If you take it, you get it is x bar plus z bar. So this is the answer. So this expression, the answer is a bar plus b bar ANDed with x bar plus z bar. So using De Morgan's law, this expression is equivalent to this expression. Okay, so some intermediate steps, students, you can skip if you want, but this is what the process is. So I have shown you this question I have taken so that multiple times I have used the De Morgan's law. So how many times we have used? One time here. In almost every step we have used here. One time here, then we have removed this here 2, then here I have removed this 3 or 4 times we have used the De Morgan's law. So very simple, replace dot with plus, complement each variable. Okay, and if confusion regarding dot and or, then dot is priority and parenthesis is the parenthesis having highest priority. So this is what the De Morgan's law. In the entire course, so De Morgan's law will be used in multiple places. Whenever you want to find complement any expression, De Morgan's law is very handy. And student, we always use one more property So based on this, a plus bc is this one. Similarly, students, a plus a bar b. So very frequently come across this simple expression. So a plus a bar b is, you can write this as a plus a bar added with a plus b. So a plus a bar is 1 and added with a plus b is basically your a plus b. So a plus a bar b is always a plus b. Remember this, sometime while solving some questions we'll be using this. A plus a bar b is equals to a plus b. So before we go into the next thing, so let us solve one question which is asked in one of the gate paper. So what is that question? So the question is this one. Yeah, this question. The Boolean expression, this one simplifies to which of the following? This is a electronics 2014 set 1 question which is asked for 1 mark. What is the simplified expression of this? So here, student, what you can do is, let me put a bracket here, right? So you see here the first variable are same, x and x are same. So the answer would be and combination of first variable, that is x, plus and combination of the second variable, that is y dot y bar. So this is what the bracket term is, plus. Now using De Morgan's law, you can simplify this. If I use De Morgan's law, then it is x bar, y bar, bar, plus is replaced by dot, then it is x bar. Is that fine? So if you are removing this, so you have to take complement of this, dot with complement of this. So now this is equivalent to x only, because y bar is 0 and 0 plus x is x. So x plus. And if you are using the De Morgan's law here, I mean to this term, so it is x plus y, right? X complement, this complement is x, this dot is plus x plus y, and this is your x bar. So this is equivalent to x plus x bar plus x bar y. X bar is 0, so this is equivalent to x plus x bar y. X plus x bar y is x plus y. How? A plus a bar b is a plus b, x plus x bar y is x plus y, which is given option D. So by knowing some shortcuts and this property, so in a very simple way, we can reach the answer in a very short time. Otherwise, you will be always turning around, right? So answer is option D for this. So now having said this, students, let us see De Morgan's law is over. Let us see one more interesting concept, which is nothing but your consensus theorem. Consensus theorem. Okay, so this theorem is a bit tricky to understand, but once you focus what I'm saying, it is very easy. So it says that this term is equivalent to this term. This term is equivalent to this term. AB plus A bar C plus BC is equals to AB plus A bar C. So how do you, what is the pattern actually? Okay, how it is same we'll see. But see, what happens is, so if you observe this expression, students, okay, so you observe the left hand side, okay, how the left hand side equivalent to right hand side, I'm explaining the logic. In the left hand side, so we have three variables in this case, A, B and C, but among the three, only one variable is there which is present in normal and in complement form. So A is the variable which is present in normal and complement form. B is present twice, B, C is present twice, C, but A is present in 2 times, but one in normal form and one is in complement form. You observe that the variable associated with this variable, which is with A, is what are the variable? Here it is B, here it is C. Whether the third term is and combination of first two, yes. I mean, I first decided A is the variable which is present in normal and complement form. With A, B is associated, with A bar, C is associated. Whether the third term is this and combination of associated variable, yes. The third term is and combination of B and C. So this is a redundant term. Answer is AB plus A bar C. Same is the story with this also. Like here again, out of 3 variable, A is present in normal complement form. So the third term, so whether it is the or combination of B and C, yes. So this is redundant, it is equivalent to this expression. And how is it happening? If you ask me, how is it actually happening? So how is it happening in the sense, you can observe here, student, very simple, not a big deal. So you have this AB plus A bar C plus BC, right? In BC, there is nothing wrong if I say it is ANDed with A plus A bar. A plus A bar is 1 and 1 ANDed with BC is BC. So with BC, I have attached this. But the function is same. BC dot 1, 1 is A plus A bar. So this is AB plus A bar C plus ABC plus A bar BC. So from this and this, let me take AB common. You get 1 plus C. And from this and this, let me take A bar C common. You will get 1 plus B. So this is AB and this is A bar C, because 1 or with C is always 1, 1 or with B is always 1. So AB plus A bar C. So you see we are getting it is AB plus A bar C. Okay, this is what the proof is. I hope this is clear. Now let us see one more questions. So this is one example and then we'll solve these all questions. So here students, you see this the point what I explained I have written here. Find an element and its complement, note the associated terms and eliminate the included term which is composed of associated terms. Find an element and its complement, like here A and A complement. Note the associated term. Associated terms are B and C bar. I mean B and C. Eliminate the included term. That means which is composed of associated. Eliminate the included term which is composed of associated term. So this is a term which is composed of associated B and C. So you have to eliminate this. This is what the consensus theorem says. In this case, students, you see, this is, let's observe the left hand side and how this is equivalent to this one. You see here among A, B, C, D, 4 variable. So A is the only one which is present in normal and complement form. Like this is A and this is A bar. So the associated term with A is B, associated term with A bar is CD. Whether the other term is AND combination of these associated terms, yes. So this is nothing but AND combination of B and C, D, B, C, D. So this is a redundant term, we can eliminate this. So the answer is AB plus A bar CD. In the same logic, let us try to answer this problem. So if you observe here, so here again 3 variables are used, A, B, C. A is used in normal and complement form, A bar A. B is used in complement form only, B bar, not B bar B, okay? C is also C bar, C bar. So you have B bar, you have C bar, but you have A bar. So how will be solving this? So again, my target is the variable A. So A is present in normal complement form. So what is the associated term with A? C bar. What is the associated term with A bar? B bar. Whether the other term is combination of these associated terms? Yes. So this can be removed. So the answer is simply A bar, B bar plus AC bar. All right, fine. Now what about these questions? ABC plus A bar D plus B bar D plus CD. How do you say it? So let me put a bracket term here, students. And if I do it, so I can write this as ABC plus ABC plus AB whole complement ANDed with D. Because by De Morgan's law, if I split it, you get A bar plus B bar. So this is A bar plus B bar. A bar plus B bar with D is A bar D plus B bar D. So this bracket term is replaced by this. And then your CD. Now you observe, students, I can assume that this AB as a single variable, right? So AB as a single variable and this is your AB complement. So the associated term with this one is C, associated term with this one is D. So whether the other term is AND combination of the associated term, yes. So this term is AND combination of C and D. So this can be removed. So the answer of this is only the first 3 terms. So you can remove this, which is your ABC plus A bar D plus B bar D. So this is a redundant term. So this is what is the consensus theorem. I believe it is clear to you. So you have to observe the pattern. Many times questions have been asked in the GIT exam. Here one more thing, students, one shortcut I would like to share you. So what is the shortcut is? So let's say I want to simplify this to Boolean expression, right? So here in the normal way, if you go, the answer is a dot a bar plus a dot c plus b dot a bar plus b dot c. A bar is 0, so it is simply AC plus a bar b plus bc. You see here again it is coming in the consensus format. So the A is present in normal complement form. Like here the associated term is C, here the associated term is B. So whether this is and combination of the associated term, yes. So this is a redundant element. So the answer is simply it is AC plus A bar B. So answer is AC plus A bar B. Okay. Now, so we know the answer is AC plus A bar B. So here one pattern I would like to tell you. The pattern is whenever you are finding the AND combination of two sum term, this is a sum term, this is a sum term, and you are interested to find the AND combination, you observe the pattern, the first variable are complement to each other. So I have told you one shortcut when the first variable are same, but here first variable complement to each other. In such case, the answer will be AND combination of inner variable plus AND combination of the outer variable. So AND combination of inner variable is A bar B, okay, this one, plus AND combination of outer variable is AC. So you get A bar B plus AC, which is this one. Right? See how shortcut this is. So let us utilize these shortcuts and solve this problem. Let us solve this one. Here you see students. So here I have this is a term, this is a term, this is some term, this is some term. I want to find its AND. So here the first variable are complement to each other. So first variable complement to each other means, so you can assume the this is the second term, this is the second term. So the answer will be AND combination of inner variable plus AND combination of outer variable. So the AND combination of outer variable, that is, I mean this one and this one, is nothing but how much? So this is ABC plus ABC plus, and if I see for the inner one, so it is A bar ANDed with B bar plus C. So AND combination of outer variable and combination of A and BC is ABC, and combination of inner variable, that is AND combination of A bar and B bar plus C. So if you simplify this, ABC plus A bar B bar plus A bar C. This is what the answer is. Okay, but without knowing the shortcuts, it will be lengthy. But you see how quickly you are able to reach this conclusion. So this is what about your consensus theorems and your De Morgan's law.